Our flexoplate has a lot of characteristics to be understood. First of all, the naming. When at school, especially at school with students, I push very much about using the correct terminology. So sometimes there are misunderstandings about what is the relief, the base layer, what is the shoulder of the plate. So we have certain items, certain parts of our printing plate that are named in a particular way. One of these is the shoulder. So when we say the shoulder of a plate, is the wall, is the vertical wall that describes the relief area. Then we have the floor that is not printing. Then we have the printing surface. We will have a certain hardness or resilience or durometer, okay, as our American friends are calling. We have a total thickness, then we have the relief thickness and the base thickness, and then we have a substrate and one component made with another material that is polyester. So if I look at the structure of a photopolymer plating sheets, and here we see the section, the vertical section of the material, we can see that we have the most important part is what we call the body of our photopolymer. This is the area where we will obtain the relief and the printing relief of our printing plate. So, and this will be made with a certain plate making technique and imaging and plate making technique. But then we have one base layer. The base layer is a plastic film, is a polyester film. And why do we have that? Well, we have that because the photopolymer body is a kind of a rubber. So when we mount it, maybe if we stretch it after polymerization, if you stretch it, it gets thinner. So we don't want to lose the advantage of having an accurate thickness of our plate. So we need to have a base layer that keeps the size of our plate undeformed. Then we have another film, another plastic film. It's a protective film. It is a film that we throw away. So it is a film that helps to keep the plate as a sandwich. Okay, it's a kind of a hard sandwich and undeformable. But we remove it and we throw it away when we have to image and process our printing plate. There is one layer, the one you see here marked with the red color. It's a layer that has a multiple function. It has a function of a primer that, let's say, bonds together the body, the photopolymer body, and the base layer, okay, attached. And then it will also provide to have a good adhesion between these two different materials after polymerization. But it has also another function that we call anti-halation layer. What is it? You have seen that we use an ultraviolet radiation, okay? The ultraviolet radiation, especially when it comes from the top, it can create certain refraction issues within the thickness of this layer. So, in order to avoid that some radiation gets scattered throughout the inner layer of the photopolymer body, this anti-halation layer has the function to absorb the ultraviolet energy, okay? And absorbing the energy, it will avoid to create unwanted enlargement of the shoulders of our printing elements, okay? So the anti-halation provides this function, but it has another function because it can also control the quantity of ultraviolet radiation that will get through the base of our plate when we do one of the most important phases of the creation of the plate, that is the back exposure. So we have a UV radiation that gets through the back of the plate. Between the protective film and the photopolymer body, we have another layer that used to be called the slip coating or slip coat layer. It's an anti-tacking layer. The photopolymer body is extremely tacky, sticky, okay? And in the past, when we used to make photopolymer plates with negative films, you know, when you were putting your film onto the plate, the film could stick, okay, and making it so difficult to move and reposition. Now, this slip coating is a very thin layer of material with a very hard polymerization. Okay, so it helps the surface to slip. Okay, so if I position any film onto this surface, I can move it freely. But this slip coating over the years, and when we started to have the what's called digital plates, the slip coating is no longer transparent, okay, but it becomes black. So the same slip coating with the same let's say property to avoid the tackiness to be sticky. So when you touch your plate with your fingers, you avoid to leave a mark on the surface of the plate. So it becomes black. It is black because it will be the black mask where the laser will image the image on when working directly on the surface of the plate. One interesting thing that you may see also within photopolymer plates is that actually their production is made similar to the liquid photopolymer plate. So the manufacturing of photopolymer plates is made upside down. So we start with the protective film that has a coating, so it's a transparent coating or a black coating onto it, and then onto this coating is applied the thickness of the body, and by means of calendars and an accurate thickness process, we can have the exact thickness of our plate. And after this, they apply the base layer. What will be the base layer? Okay, so the plate is manufactured upside down. Okay, so this is how plates are made, and let's see what are the characteristics of the material. So as you were asking, to understand what are the differences between the different materials, different colors, different hardness. So let's see what are the characteristics that are quite important for us. Okay. And sometimes I go to a printer and I say, I like that pink. The pink plate is good. No, the green one is better because it has a better ink transfer. Oh, but the yellow one has a very fantastic resistance. And they speak about colors, and they do not know what's behind the color. Color is just a colorant to create a differentiation of the product on the market. Sometimes the colorant has a certain purpose, but not so frequently. So let's see what are the most important aspects that we have to care about in our flexographic printing plates. And we start with the thickness. Okay, is how many of you are working so let me enlarge here. Raise your hands if you are working. Let me open this one here. How many of you are working with thin plates like 114 or 170? I do not see your hands. Open the participants. You can click on at the bottom when you okay, Antun has raised the hand. Only Antun. And the others? Are you working with the thicker plates? like you can also activate your microphone if you want, huh? Is any of you working with thick plates, like high thickness for to make multi-wall bags or corrugated applications?
No answers in chat.
Yeah. Ah, okay. The answers are in chat. Okay, here we are. Okay. Tatiana, is the recording still going on?
Yes, it
Ah,
is.
okay, because I don't see it from my deck here. Okay. 114, 114. I think the thickness 114 is the one that is so widely used. Um, it's interesting though that I will show you later that in some areas in the world, okay, we have 170. Okay, um, for high quality flexible packaging, the 114 is taken back, and because a much better high quality is provided with the 170, while the 170 is normally a thickness that is let's say considered for obsolete label printing, right? Any of you working with the thicker plates like 284 or 394, anything like corrugated printing? No, I think not. Okay, let me close the chat here. Otherwise, I have my screen clogging everywhere. Very good. So normally we consider the thin plate, you know, the 114 and 170. Okay, raise hands. Sometimes I can see the raise hands and the chat. Okay, 170 soft and hard G2. Okay, okay, very good. So the thin plates 117, 170, 114, and then we have the medium gauge. Actually, the first photopolymer plates were made in this medium gauge, right? So the very first photopolymer plates in solid sheet, they were made in the 112 thousandths of an inch, 284, because in combination with the double adhesive tape, non-compressible tape, 0.30, it was providing one total thickness that was within the 3 millimeters of the undercut of the impression squeeze, and that was the size that was typically used all over the world for printing. Then we go to higher thickness, and here we have all the applications within multi-wall bags, you know, for pet food or large containers, special applications, or corrugated board. Although today corrugated board is moving quickly, especially for the high quality corrugated board printing, to thinner plates. So normally we have the good quality, the highest quality corrugated board today is printed with the 284. I also have some users running 170 plates on corrugated. Okay, so they have a compressible underlayer under a compressible blanket below behind the plate, and they run with 170 plates. Now, of course, every plate has its own total relief, and it has its own um, um, engraving relief, right? So typically, we keep the relief as low as possible to avoid that our plate gets deformed during printing. Okay, so if we keep the engraving, the depth of the relief smaller, we can ensure that the graphic elements are printing correctly without or with reduced deformation during printing. So the higher we go to with the total thickness of the plate, and of course the more we have engraving depth. Typically, again, when we go to the high quality printing, we go to thinner plates. It is interesting to note that the 114 printing plates have a polyester base of almost 0.18 millimeters. Okay, so it's a rather thick polyester. And the other plates, 170 upwards, they have 0.13. It looks like nothing, but this difference makes a lot of difference when you are talking about plate lifting, so head and tail lifting of the plate, and limpness of the plate. For this reason, when working with inflexible packaging, especially on small diameters, 170 is the preferred plate because it has a thinner base and it wraps around on cylinders in a very nice way. Then we also have other special applications like plates for vanishing, lacquering, or aluminum base, but and these are it's a different story. Okay. When we measure the total thickness of the plate, then we need to consider that this thickness is the thickness that we get after the full and correct processing of the plate. If we measure the raw plate, we would discover that it is not exactly this thickness. Normally, especially with the so-called digital plates, the thickness of the polymer is higher. So we say that they are over extruded and they get the correct thickness at the end of the correct processing. So we measure the total thickness and we need to we can expect a tolerance of plus minus 20 microns, okay, on the thickness of our plate. Same tolerance when we measure the floor thickness, and by difference we know the depth of our printing relief. Okay, so here is a measurement made on a 114 plate, so it's a 0.55 base. One thing I frequently hear from printers is, give me one printing plate with a very nice engraving. I want to see the relief areas very nicely up, because otherwise, if they're not very nicely engraved, okay, the non-printing areas will print dirty. They will pick ink when printing, and I will have dirty printing. Well, when I hear this, it means that there is something wrong, some mechanical problems on the press, because the only reason to have a very thin floor is that there is some problem on the press. A good floor is typically more than the half of the total thickness of the plate, right? Having a high floor, it means also much more stabilization of the printing areas. It means less solvent usage. It means shorter processing and plate making times. We have better mechanical resistance, so we have so many advantages. But in the case of mechanical problems, if I think that my Anilox roll can peak at this level, okay, it means that we are squeezing our Anilox roll down to the level of the base, which is not correct. Okay, so if the floor of our plate is picking any ink, it means that there is something wrong in the setup of impression settings. The correct impression will actually compress a little the surface of our printing plate, but for no reason it will reach the level of the base. Some years ago, I think Dieter Niederstadt, he is in Azai today, when he was at BSF, he published an article about the correct relief depth of the printing plate, and it came out that with 300 microns you can already compensate the need of corrugated printing. So with a 0.3 millimeters relief depth, you can already do whatever you want in a properly calibrated, mechanically calibrated press. Of course, when we measure the thickness of our plate, we need to use the proper instruments. In particular, you have to consider to use contact feelers or thickness gauge measurement with with an area of at least 10 millimeters diameter, and don't exaggerate with contact pressure. So if you are squeezing too much your plate, you will get a wrong measurement of your thickness. Screw units like the one in the photo are absolutely not suitable for measuring the thickness of a flexography plate. As a printer, when I'm in the printing room, you know what I do, I take my plate and I put it on a table, and at the first glance, just the color of your plate can tell you if there is uniformity, okay, in thickness, because thanks to the transparency of your photopolymer, you can notice immediately if there is any unbalanced thickness, if your plate is not well balanced. So just take a look at your plate whenever possible, and on a white table, and then you can actually see if there is any imperfection, and then of course check with your gauge meter. So the thickness, we have seen the thickness. Second step is the hardness. Okay, what is the hardness? The hardness is is an indication of the resilience of the plate. So resilience of the plate is the property by which the material returns to its original thickness after compression. So being a rubber-based material, we actually need our plate to return to its thickness 2 times every rotation, because we have one compression against the annulus roll, one compression against the substrate. And keep in mind that flexography is the only conventional system that has a soft printing plate. All the other conventional systems like letterpress, offset, gravure, they have a hard printing plate, okay? Non-compressible. Flexography is the only printing system that has a compressible printing plate. So therefore, we need to be very careful in all the aspects that are connected with the compression of the printing plate, including the hardness. So the hardness is measured with instruments that perceive the how much one feeler gets into the thickness of the material, and we have different ranges of hardness. Normally we have the very soft plates that are used for corrugated printing, for corrugated board, and where we normally need to have a slightly higher impression setting to provide printing, or we need to adapt the surface to the irregularity of the substrate. Then we have an intermediate hardness that we use for preprint, multi-wall bags, and so on. And then we go to what we call the hard plates. Okay, the hard plates made for printing onto foil, packaging film, paper, wide web, label printing, and so on. So these are the 3 major classes of hardness. Be careful, because when we talk about the hardness, we are talking about a number that is measured with a certain norm, that is the DIN 53505. What does it say? This norm says that we measure the hardness of the material in these short degrees, but the norm says that you have to measure it on a thickness of at least 6 millimeters, and our plates are thinner than 6 millimeters, right? So if I measure with an instrument like this, with a handy durometer, if I measure a plate of 114, as I'm doing here on the table, I will find a different value. So maybe my plate vendor says, well, this plate is 60 hardness, and then you measure and it is 80. Why? Because we are measuring the same rubber, the same photopolymer, but on a smaller thickness. So there is a difference between the documented hardness of that material and the specific hardness that we measure. Okay, so if I take the same photopolymer material, okay, maybe my plate vendor says, okay, this plate is 55 degrees, sure, A. And you can have it in 114, 284, 394. You can have different thicknesses. Okay. So, but if I measure here, if I measure here my plate, I can find 75. Okay. And if I measure here, I can find 65. But it's the same rubber. Okay. Exactly the same rubber. Only that it is specific to the thickness. Okay. So when you consider the evaluation of hardness, please keep in mind what you are actually measuring. The hardness is a fantastic method to control if the plate arrives at the printing department with the same consistent quality. Sometimes I have a solid or a barcode or a text or image that get different levels of polymerization. A different level of polymerization will result into a different hardness, meaning different impact, different impression settings, and also different ink transfer. Sometimes the hardness is confused with the ability to transfer ink. Normally we say, well, I have a rough substrate, like a vergeting paper in labels, or a rough surface in white web. Then I prefer to have a soft plate because it transfers better the ink. Or I